microcontroller. Microcontroller incorporates the processor, memory, and many peripheral modules into a single VLSI chip. SRAM and flash memory peripherals such as timer, parallel I/O ports, serial communication interface, AD converter, and DA converter, and so on, are often included in a microcontroller. Include all these things. Do you know this AD? Analog and digital. Analog
to digital.
Analog and digital. SDA is digital and analog. The digital signal is in the computer. If you want to send some analog signal to a computer, you must have AD converter. Memory, flash memory is used to store program memory, whereas SRAM is used to hold dynamical data. Memory is store dynamical data. Microcontrollers have been used in every application that requires a certain amount of intelligence, such as some washing machine, air conditioner. Our air conditioner has a microcontroller. Embedded system, a special purpose computer system designed to perform a dedicated function. An embedded system performs one or a few predefined tasks and often includes task-specific hardware and mechanical parts. Task-specific hardware and mechanical parts. That is very important. Not found in a general purpose computer. A general purpose computer, not an embedded system. A project designed with a microcontroller or a microprocessor that the user can install different software so that the product can perform many different functions and not embedded product such as phone or your computer, your laptop is not an embedded system. Next, we introduce the wireless sensor network. A wireless sensor network, WSN, consists of distributed independent sensor nodes that are meant to monitor physical or environmental conditions. Wireless sensor network consists of many sensors. Sensor nodes. Sorry. Sensor nodes communicate with each other and exchange information and data via wireless communication. Sensor nodes collect environmental information and forward it to a base station. The base station then sends the information to a wired network or activates an alarm or an action depending on the type and the magnitude of data monitored. WSN consists of sensor nodes, base station, sensor node and base station. There are many sensors and need one base station. Is one base station. WSN typical application includes weather and forest monitoring, battlefield surveillance, physical monitoring of environment conditions such as pressure, temperature, vibration, pollutant, or tracking human and animal movement in forests and boards. You know the house guard. Yeah. You can put many sensors around your house.
Oh.
Yeah, around your house is a wireless sensor network. A wireless sensor network may consist of from thousands, hundreds to thousands of sensor nodes. A sensor node consists of a radio transceiver and with an antenna, a microcontroller unit, an electronic circuit for interfacing with sensors, memory device, and an energy source, usually a battery or a device that can harvest energy. Which means a sensor node is like a computer. A single computer have a power, single computer. Yeah. This we call the sensor, not just a sensor. It includes MCU and the sensor. Yeah, work together. Base stations have enhanced capabilities over regular nodes as they are expected to carry out compound processing. Base stations collect the information from the nodes and make decisions. The main function of a sensor node are sensing and sending data. The topology of WSN can vary from a single star network to an advanced multi-hop wireless mesh network. A simple star network means the base station in the center and the sensor around it. Advanced multi-hop wireless, this means one level, two level sensor, sensors. The propagation technology between hops of the network can be routing or flooding. Routing and flooding is internet technology. Yeah, tell us information how to go. As an example for the WSN, forest fire alarm system. Distribute the sensor on the mountains. So when one sensor sensor the fire and transfer the information to another sensor. Another sensor transfer to another one by one to the base station. The Internet of Things, in Chinese we call the 物联网, is connect everything. LOT describes the coordination of multiple machines, devices, and appliances connected to the internet through multiple network. Objects can be tablets, consumer electronics, vehicles, monitors, and sensors equipped with a communication capability that allows them to send and receive data. To connect to the internet, every object is required to have an address to identify itself and has a processor to execute the networking protocols and applications. Everything has a address on the internet. Everything have address. We call it IPv4. Do you know IPv4 address?
Yeah.
IPv6 address. Yeah, IPv4, IPv6. If we can have IPv6 address, everything can have its address. Yeah, everything has its address. Identify itself and has a processor to execute a networking protocols and applications. LOT brings convenience, comfort, and efficiency to our daily life. Memory technology. Three major memory technologies in use: magnetic, optical, and semiconductor. Magnetic memory. Three major magnetic memory technology: magnetic drum, magnetic tape, and magnetic disk. Magnetic tapes only used for archive purpose. Magnetic disk, also called hard disk, we used on the computer. Is the only magnetic in use today. It is still used in most PCs, workstations, servers, mainframe computers, and supercomputers. The magnetic disk can store many things, many files. So we often use it on our computer. Optical memory, we call it CD or DVD. There are two optical memory technology used: compact disc, means CD, and digital video disc, DVD. CD was introduced in 1982 and has been obsolete today. DVD was introduced in 1993, but the unified format was finalized in 1995. A single-side DVD with 12 centimeter diameter can hold 4.7 GB of data. A DVD can be read-only and read-writable. DVD has also become very popular today. Not many computers included. Although DVD is popular today, but many computer has no DVD because we use the USB disc replace the DVD. In 2006, A newer DVD technology called Blu-ray disc was introduced. The Blu-ray disc DVD can hold 50 GB of data. It's very large. Semiconductor memory. Dominant memory technology used in embedded systems. Semiconductor can be classified by volatility, and writability. Classified based on volatility, volatile memory, and non-volatile memory. Classified based on writability, RAM and ROM. The volatile memory, this means if you power off the memory lost the data, Non-volatile memory is keep the data when the power off. RAM, random access memory. RAM is volatile memory. And ROM is not volatile memory. It's non-volatile memory. RAM is volatile memory. ROM is non-volatile memory. Random access memory can be volatile or non-volatile. Sometimes we can be different. Processor can write into and read from RAM. Processor can read from or write into any location within the RAM chip for roughly the same amount of time. There are 4 types of RAM: DRAM, dynamical RAM, static RAM, magnetoresistive RAM, and ferroelectrical RAM. Is 4 types of RAM. Mostly we use dynamical RAM.
That we can change anytime.
You change.
That we can change anytime.
You can change anytime. Yeah.
Dynamic.
Yeah. Dynamical random access memory use 1 transistor and 1 capacitor to store 1 bit of information. Data is stored in the capacitor in the form of electrical charge. Need to be performed periodic refresh operation to maintain the contents of memory cell with the presence of a power supply. The fresh period is from a few milliseconds to over hundreds of milliseconds. Data is stored in the DRAM need to be refreshed. Period refresh operation. Static random access memory use 4 to 6 transistor transistors to store 1 bit of information. Four to 6 transistors. In the DRAM, use one transistor. So you can know that the data stored in the SRAM is reliable. Use 4 to 6. Transistors to store 1 bit information. As long as the power is present, the information stored in the SRAM will not be degraded. There is no need to perform periodic refresh operation to memory cell. Magnetoresistive random access memory were first developed by IBM. MRAM uses a magneto moment to store data. An MRAM chip combines a magnetic device with standard silicon-based microelectronicals to achieve archive the combined attributes of non-volatility, high-speed operation, and unlimited read and write endurance. Its characteristic is unlimited read and write endurance, but the magneto-resistant speed, reading and writing speed is known. So magneto resistor is not used often. IBM is a major company that researches and produces MRAM chips. This company was acquired by Cypress in 2015. The product can be accessed at 667 million Hz, about 1.5 nanosecond access time. Ferroelectrical random access memory use the property of a ferroelectrical crystal to store data bits. Use the property of ferroelectrical crystal. Much of the present FRAM technology was developed by Ramchain International. Ramchain is a company. Ramchain has been acquired by Cypress in 2015. F1 has been produced as an individual IC chips and also built into the LAN chip memory of 8051 microcontroller. At the time of this writing, FRAM commercial product from Cypress has achieved 20 nanoseconds access time. Read-only memory. The types of read-only memory mask the ROM, PROM, EPROM, EEPROM, and flash memory. PROM, programmable read-only memory. One-time programmable ROM one time. EEPROM, SB-ROM, is electrically programmable read-only memory. EEPROM, electrically erasable program read-only memory. You can use the electric erase the data you store, and rewrite again and write again. EEPROM is convenient to use. Only EEPROM and flash memories are still being used as a discrete product. The flash memory we use the USB disk flash memory. EEPROM we use it on the single chip. MROM is simply called ROM. Its contents are programmed during the manufacturing time. PROM was invented by Chinese engineering Wen Zhenzhou in 1956. PROM uses fields for programming purpose and it's one-time programmable only. It is already an obsolete technology. This technology has been thrown away. EEPROM used electrical voltage to program the chip, but needed to be erased before writing data. EEPROM. Inconvenient. EEPROM must be erased by strong ultraviolet light. Erased by UV light. The UV light usually has a wavelength of 235 nanometer for optimum erasure. EEPROM are recognizable by a transparent of fuse cores window on top of the chip package. If you found a chip has a window on the top, maybe it's EEPROM, maybe it's DV-ROM. All the PC BIOS are stored in the EEPROM chip. Electrically erasable programming read-only memory EEPROM was developed by George Peligros at Intel in 1983. EEPROM can be erased and programmed using electrical voltage. EEPROM allows the user to selectively erase and program a single location, a row, or the whole chip. Flash memory was invented by Fujio Masuoka while he was working for the Toshiba in 1984. Flash memory is invented by Japanese. Flash memory incorporates the advantages and avoids the drawbacks of the EEPROM and EEPROM technology. Incorporate the advantages and avoid the drawbacks. Flash memory can be erased and programmed in the system without using dedicated programmer. Without programmer. Flash memory does not individual location to be erased. The user can only erase a block or the wire chip. Today, the BIOS of most PCs are stored in flash memory. Flash memory has been used in flash disk memory, we call the SSD, solid state drive, personal digital assistants, digital cameras, cell phones, and so on. Next, I introduce the memory system operation. A simplified memory system is shown in figure 1.4. This is a microprocessor. This is the memory. The memory system consists of one or multiple memory chips. A memory location may hold any number of bits, hold data. The memory system can be accessed one location at a time. This is enforced by implementing a decoder on the memory chip to select one and only one location to be accessed. When the microprocessor wants to read data in the memory, firstly, the microprocessor sends the address to the memory, and then gives the signal write or read. When the microprocessor reads, it gives the signal RD to the memory. Or when the microprocessor wants to write, it gives the WR signal to the memory system. Then the memory system gives allow the microprocessor to read or write the address and get the date. Memory read operation. The processor sets the RD signal to indicate its intention to read. Read operation give the RD signal. The RD signal is connected to the output enable signal, OE, which enables the memory to output date. The processor sends address on the address bus. After the read access time, the memory system presents the contents of the specified location on the data bus to be fetched by the processor. The memory system presents the columns, present data on data bus. After fetching the memory contents, the processor de-assert the RD signal. release the address and the data bus. This completes a read cycle. This when you operate a memory, the memory and the microprocessor working together like this. When you make a program, you need how it works. So you can understand. You must understand this process. Memory write operation. Processor place the data on the data bus, on the data bus, and place the address of the location to be reading on the address bus, and then set WR and RD signal to 1 and 0. WR signal and RD signal to 1 and 0. Memory write operation. Memory system uses its decode to select a location and write the value on the data bus into the selected location. The actual RD and WR signals may be set no indicated as RD bar and WR bar, which means if you have a line on the symbol, means the lower voltage means 0. 0 is effective. Program execution. To enable computer to execute program immediately after power on, part of the program must be stored in a non-volatile memory. The start program performs system initialization. After system initialization, the start program loads additional program from secondary storage for execution. Different from ordinary computer, the whole applications program of an embedded system is stored in non-volatile memory and ready for execution immediately after power off. Both general-purpose computers and embedded systems are required to use program counter to keep track of the next instruction to be executed. Ordinary computer and embedded system is different. The microcontroller is the embedded system, so all program is stored in the non-volatile memory. In our computer, when we power on the computer, the systems store the data from the disk and execution. But in the embedded systems, the program is stored in the memory, so they can be executed immediately. Program execution. Program count is constructed using D flip-flops. D D flip-flops work like this. When the clock rise, D is 0, Q is 0. D is 1, Q is 1. Otherwise, the clockwise 0 or 1, the D state not influence the Q. The Q keep the status. Program counter is constructed using D flip-flops. The program should be designed to support all possible program flow chain, i.e. sequence program execution, conditional or unconditional branch, jump to certain location, etc. The program counter should be forced to be to a fixable location, maybe location 0 after power on to perform system initialization. A possible implementation of program counter that meets these requirements are shown in the figure 1.6. When processor is power on, the program counter is forced to 0. If the conditional branch is executed and branch is taken, then branch distance is added to the current PC value. If the jump instruction is executed, the destination address is loaded into the PC. Jump. If the instruction being executed is not a flow control instruction, the PC is incremented by 1. Start a program execution. The value of program counter must be known when the computer is powered off. The program counter of most microcontrollers are forced into 0 when they are powered up. The processor starts to execute instruction from address 0. Mostly address 0. Other address is possible. Now we see the instruction execution process. Read the next instruction from the memory location indicated by the program counter. Decode the fetched instruction into a set of commands and all signals for each of the components of the processor. Increment the program counter so it points to the next instruction. Read whatever date the instruction required from memory. The location of this required date is typically stored within the instruction code. Provide the necessary date to an ALU or register. If the instruction requires an ALU or is specialize the hardware to commit, the processor instructs the hardware to perform the requested operation. Write a result from the ALU back to the memory location or to register or perhaps an output device. Finally, jump back to step 1. It's a loop. Instruction execution process is a loop. Okay, if you are child, we can have a break. Okay.
Yeah.
Okay. Intel in 1980 for use in embedded system. Very popular in the 1880s and 1890s in US and even in China. Many companies licensed the design of the 8041. There is a mining company made the microcontroller based 8051, and they introduced their own versions of 8051. STC Micro in China is one of the licensees. STC Micro is a Chinese company. They built microcontroller. 8051 vendors differentiate Okay, thank you. Their products by adding peripherals and even change the processor design. The 8041 Windows integrates many peripherals and into the microcontroller. The original 8051 uses external crystal to generate clock signals to control instruction execution. 12 crystal clock cycles become one machine cycles. The original microcontroller is 12 crystal clock cycle become one machine cycle, but the newer 8041 use one clock cycle as one machine cycle. Instruction execution is controlled by machine clock cycle. The features of original 8041 MCU: 8-bit, 6-bit address, 6-bit address, 8-bit data. It's different. 8-bit data, 16-bit address. 6-bit address bus, which enables 8041 to address up to 64 KB of program memory and 64 KB data memory. 128 bytes of on-chip SRAM, 4 KB on-chip ROM, 48-bit bidirection, 8-bit bidirection, which means four ports. Every port has 8 bits and 8 bits. One UART model, serial port. 2 16-bit timer, two timers, to never interrupt priorities. Power saving mode. We can change the power mode and save the energy. The future of 8042. 8041 is a subset of 8042. So 8042 includes all features of 8041. Double internal SRAM to 256 bytes, double on-chip program memory, and a third timer. There are three timers. Other features are identical to 8041. It's a STC microcontroller manufactured by Chinese company. It's compatible to the 8041. When we do some experiments, we use STC microcontroller. Just know something about this STC microcontroller is the same to the 8041. Is the same to the, but something is different. It's 1 clock cycle per machine cycle. It means that 1 clock cycle is 1 machine cycle. It's 12 times as fast as 8041. Add many peripherals. The original 8041 including two timers, but the STC microcontroller maybe include more. Yeah, more timers, more UARTs, and even include ADC, SPI, and iPhone C, I2C. STC microcontroller integrates many peripheral into the chip. Well, when we study the 8041, the code is compatible to the STC microcontroller. Next, I introduce the hardware structure of microcontroller. The PDF books I give you, you can read the books, so know something about the hardware structure. The hardware structure of microcontroller, including logic structure and signal pins, internal memory, parallel I/O ports, clock circuit, and timing, working models. This feature I have already told you. You just know something. The future of 8041 core, the core of MCS 51 devices, the original members of MCS 51 family. 8-bit CPU, extensive Boolean processing, 64 key program memory, 64 data memory, 4 kilobytes of on-chip program memory, 128 bytes of on-chip data RAM, 32 bidirectional directional and individual addressable I/O lines, two 16-bit timer counters, four duplex U arch, 5 source interrupt structure with two priority levels. This is the core of 8041. CPU, this core is, if you know something about your personal computer,
Central processing unit.
Microcontroller is a small computer. It's a small computer. It has a CPU, the bus. This is the bus. This is the bus. So
Bus connection.
other devices connect to the bus, just like ROM, RAM, timer, and serial port, other I/O ports. Bus extender control. This core is the same as PC, personal computer. The microcontroller is a very small PC. We can think it like this. Think like this. You can understand the microcontroller core. What?
Did you check right now? Your phone?
My phone.
Yeah. Did you check right now?
You mean your email?
Yeah, you got email. Right?
I'll check it.
Yes.
Oh, okay.
You got it?
I get an email.
What is
I can confirm the email. Okay.
You are my recommendation. What is this email? Can I see it?
I have confirmed. Okay, you can try to log in.
You just recommend this email.
Casper.
Maybe now I can access because you recommended me to research.
I have already confirmed for you.
Yes.
You can log in. Okay. Okay. This CPU is the core of a microcontroller. The OSC give you the time sequence. The interrupt control control the interrupt priorities. The ROM store the program, and the RAM store the data when we running the program. The timer gives a timer signal. And the I/O ports gives a communication to the other devices. And the serial port is the same. This is for bus extend. This is the internal logical structure of 8041, but the type is 80 18 line C51. Yeah, from 18 mil cooperation. 18 mil cooperation is different cooperation. We can know the S9 which means inside the chip, this means inside. So outside the chip, we can see the P0 to P0, P1, P2 port, P0, P2, P1, P3. This is a working pin. This is working pin. We call pin. Inside the red box. This wall is inside the chip. Inside the chip. This is for the P0 and P2. This is for P3. This is for P1. This is for P1. This is RAM memory. This is RAM memory. Here is for this CPU processor. Here is for CPU processor. This is arithmetic and logic reach. This is arithmetic logic. This is for timing and control. This is for timing and control. I can divide the core of the microcontroller to different parts, but you needn't. If you want to totally understand the function, you must use the microcontroller. Maybe your project, understand the project. Yeah. If you make some experiments with your microcontroller, you can understand the working sequence. So after we learning something about the language, maybe assembly or C, I give you a experiment board, experiment box. Yeah, experiment box. Everyone has one box. You can take to your dormitory. Yeah. I give you the task. You made your own design. Okay. After you learn something about the language, C language, or maybe C language is better. Because the assembly language is difficult for a complex project. Yeah. if you want to understand the 8041, you must know the pin. You know the relation, working relation sequence between the pins. So you can understand the pins, signal pins, according to this block diagram. This block diagram. This is P1. P1 here is P1. This is P0. P0 is here. P0 is here. RST, RXD, TXT, or outside this block diagram. Last time I give you the PDF book. There has a specific specification on the PDF book. Yeah, you can check the PDF book and give you your specification. When we use the 8041, we use the P0, P1, P2, and P3 interaction with the device. So mostly we design the project. We design the interface with other devices. This is a table about the function of every port pin. Next, I introduce the internal data memory. The data memory is for running. When the program running, the program uses the data memory store the temporary data. The 80 line C51 has 128 bytes of on-chip RAM, plus a number of SFR. SFR means special function register. This structure of internal data memory. The lower is divided two parts. The lower and the upper. The lower 128 bytes is for direct and indirect addressing. The upper 128 bytes is for direct addressing only. The lower 128 bytes of internal RAM. This area can be divided into three parts. Register area, bit addressable area, and user RAM area. The register area is used for R0, R1, R2, and R3 register. There are four banks register. You can use any of them. Bit addressable area, it means we can access the bit. We can access the bit. Sometimes we can only access the bytes. If you want to access the bit, you must use the bit accessible area. Bit accessible area. User RAM area. User can use the user RAM area to store the temporary data when your program is running. For banks registered is 1, 2, 3, 4. This is for register. R0 to R7. Here is bit addressable space. Here is user RAM area. When we program our program, when we're programming, use the assembly language, you must know how to arrange your memory. Yeah, you must know because if you assembly language, everything you need to do it by yourself, including the memory arrangements or other address. Yeah, you must decide some where to put your data, where to put your table. Everything you must decide by yourself. Register area, register bank 0, 1, 2, 3. The addresses in this area are 00H through 1FH. The first 32 bytes. This area is grouped into 4 banks of H registers. 2 bits RS1 and RS2 in program state words are for selecting which register bank is in use, which means when we set RS1 and RS2 to 00, we use bank 0. 01 use bank 1. 10 for bank 2. Reset default is to register bank 0. If you forgot to set which bank to use, the default bank is bank 0. This enables more efficacious use of code space. Since register instructions are short, then instructions that are used direct addressing. Reset initializes the stack point to location 07H. So, in fact, the stack began from 0HH, but 0HH to 0FH is a register area that will be used in program. So we can often set stack area in 30H and to 7FH. 7FH. It's maybe a little complex.
Yeah.
Yeah, yeah. Sometimes you must understand how to arrange the memory,
Yeah.
So you should read the PDF book carefully. Yeah. When I first studied the microcontroller, I feel confusing. I don't know
How to work?
how to work. I don't know. I can do anything.
Same for us.
Yeah.
Same for us right now.
So after I finish my books, I know something about it. But when I was reading the book, I don't know anything.
Same position for us right now.
Yeah. It's a bit address area. This bit address. Do you know the Chinese word? This bit address 位地址，位地址。位地址 Chinese Chinese 地址。This 单元地址byte address. Byte address. This bit address. Yeah. You can access the memory just from 00H to the 01H according to the 20H byte address, or you can use the bit address 00 to 07. Yeah. If you use different address, access the same location. Yeah. This is special for you to use byte address and bit address. For example, this bit can be addressed in two ways. Bit address, for example, 20HH. 20HH, you can use it. 20H. Yeah, here is 20HH. Bit address, for example, 25H point 0. 25. 25H. This bit is 25H point 0. This is point 1, point 2, point 3. This is point 7. 25H point 0 is bit address 20HH. They are equal. Use RAM area. Use RAM space 80 bytes. The addresses in this area are 30H through 7FH. Stacks always are arranged in this area. If the stack point has been initialized to this area, enough bytes should be left aside to prevent expedite destruction, which means you must give enough memory for your stack point. Up 128 bytes of internal RAM. For 51 serials, the up 128 bytes is only used as SFR and can only be accessed by direct addressing. Addressing space HH to FFH. For example, this is correct. This is wrong. This is wrong.
Why?
This only be accessed by direct addressing. This is direct addressing. AA to P0, AA to P0. This is indirect. Direct addressing must give the address. Indirect, you call address from the other register. This is direct. This is indirect. You understand? Direct and indirect. If you use the direct addressing is correct, but if you indirect addressing, it's wrong. Only be accessed by direct addressing. Must notice.
What shows that we are using the address of a register in the second example?
You mean you can say again?
Why do you say that we are using the address of register in the second example?
In second example.
Where is the register?
Where is the register?
Yeah.
This register. The register is R0.
Oh, okay.
R0.
Alright.
This data store. This data is address. Just a number. Store in the R0. Then use 8 symbol. Call the data stored in the R0. This symbol, 8 symbol, is called address stored in the R0. 8 symbol is core address. Core address. This one is just called use the address directly. This is used indirectly. So this is wrong. As a special function register, 22 special function register. One not addressable is for PC. 21 addressable. 21 can be addressable. You cannot change the value of PC. Which means you cannot change the data stored in the SFR1. You can understand? You can change the data stored in the PC. You cannot change the data stored in the first address in the FLR. Other address in the SFR can be accessed.
So now what is the example of type of data which is stored in SFR? Is it operating system or what type of data?
You can see it again.
What type of data?
What type of data?
That is stored in SFR1.
SFR1. And SFR1 stores SFR1 store the code, store the code using by current processing.
Current processing.
When the microcontroller run, there must be some places to store the code running by the microcontroller. So the current code stored in the SFR1. This will only be modified by the microcontroller itself. User cannot modify this value. Cannot modify. We need to remember the address. We can just use the symbol. Just use the symbol. You know the symbol. ACC, accumulator, B register, PSW, program status word, SP, stack point, DPTR, data point, DPL, no bytes, DPH, high bytes, P on 0, P1, P2, P3. We didn't to remember the address. We can just use the symbol when we program. There's a point, which means bit addressable. This means bit addressable. Which means you can just like P0.1, P0.0, you can use like this address. This IP interrupt priority control E interrupt enable T mod TCOM TL TH0 TL1 TH1 SCOM serial control SBUF serial data buffer PCOM power control. This is a picture shows the address table of bit addressable. Mostly we don't remember the address. We just remember the symbol. Just remember the symbol is okay. Yeah, you know the symbol. You just use the symbol to use the address. This is the PSW, program status word. Every bit has its use. PSW point zero, parity flag. PSW point two, overflow flag, which means when your data is overflow, this bit will be set 1. Register bank select bit 0. This 2 bits is for register bank selection. Flag 0 available to the use of general purpose. This is PSW point 6. Auxiliary carry flag, which means just like the carry flag. If you carry one bit. This PSWC is used for carry flag. Sometimes we use just C, represent CY. C for CY, A for AC. When the microcontroller is reset, the default value for the register PC is 00, AC is 0, B is 0, PSW 0, SP is 07H, DPTR is 0. Just when we reset the microcontroller. Stack operation. When we have some interruption, when you're running your program, something is happening. You must interrupt your program. So you store the current status into the stack, and execute the interrupt. After your interrupt is finished, you get your state from the stack and return to your program. You can understand what? Yeah? If you can understand what I said, you can talk to me, okay? When we have a rest, we can talk about something about, yeah? This is we use the stack when we make our program. Stack operation for saving breakpoints and scene in invoking subprogram and interrupt option. SP stack point indicates the address of the top of the stack. This assembly instruction use push or pop. Push put the data into the stack. Pop get out the data from the stack. when the push option is done, the SP plus 1, SP plus 1. SP is the address of the top stack. So a stack just like just like a box. You put something in the box and the top is higher. Top is higher. When you get something out of the box, the top is lower. Which means when you put something firstly into the box, you must get out lately. Which means first in follow in first get out, first out. Yeah. Pop operation, read this, the SP decrementer. Reset initialize the stack point to location L7H. Often we set stack error in 30H to 7FH. Okay, maybe we are all tired. We have a class next time, okay? Thank you. All. If you have anything, maybe I can tell you clear. You can we can talk about. Okay. Okay.
Yeah, Laushi, can you repeat again? What is the use of stack operation?
What?
The meaning or the importance of stack operation. Stack operation.
Loud, say loud. We can see.
Laushi, the previous slide. Yeah, the stack operation.
You know how to work stack operation.
Yeah, please.
Oh, okay. If you just this bottom is a stack. When you put something into the stack, so you put something into stack. Put 1, put 2, put 3. When you get something out of the stack, you can get out from the top. Yeah, from top. So if you put it into the bottom firstly, you must get out the lastly. Yeah, you can understand. Yeah. In Chinese we call 后进先出. Can you understand? 后进先出 which means 最后进去的第一个出来。Okay?
Yeah, we get the point.
You get the point?
Yeah. You mean the first to enter, it will be the last to come out? Yeah.
Like flower pot box.
Yeah. This is how stack work. Yeah. Okay. Okay. This is our class today.
Okay.
Thank you.